And welcome back, students, to our next lesson in our review. Let's really briefly talk about classes. Right? And when I say briefly, I mean briefly because remember, Programming 1, we took 2 chapters to spend time on these to divulge into it. So we're going to go kind of fast and condense those 2 chapters down to one lesson. So it may not be as much time as you would like to spend on them, but you should have that experience to build on. So we're just going to kind of go in a fast recap here. So remember that in Programming 1 and in just programming in general, we're going to use classes to create objects within the programming language, in this case Java. Now classes can be placed in the same or separate documents as the main method. Generally speaking though, main method is its own class and each helping class is its own. Reason why you want to do that is because it's easier then to separate things out. You don't have to worry about different things acting weird, and it's a lot cleaner in its presentation. And it's easier to look through too. Looking at a document with like 1,000 lines of code trying to find the one thing that's going wrong is a lot harder than maybe looking through 5 different documents that are maybe only 100 lines of code each. Just to kind of make a quick point. Now, classes have several properties for the methods and variables. The 2 most important ones that you remember that are public and private. Public means that they're accessible by the whole program. Private means they're accessible only by the class to which they belong. Right? Again, I'm kind of condensing stuff down really quickly here because we're just going really fast. There's some more nuanced stuff that I won't really get into completely, but if you have your notes from Program 1, you'll probably be great because then you can remember all the little nuances. All right, let's jump right then into methods. Now, all methods generally should be marked as public unless they're a helping method, in which case then we mark it as private because we don't want the user to be able to access them. So the methods that we encounter typically are constructors. These are methods that define variables and properties of a default object. They can have either no parameters, which in the case we call it a no arg constructor, or they can have parameters for each of the defining instance variables. You also have mutators, which are methods that change the values or the variables or the properties of an object. You have accessors, which are methods that access or return values of a method, or in some case an object. Helping methods are methods that are usually private and aren't accessible by invocation. Now you can't type, method dot something and it'll come up because it's private. All right, variables. All variables should be marked as private unless otherwise noted. There are occasionally times you want instance variables to be public. Like if you remember our final project in Program 1, we had some public instance variables because we wanted them to be accessible beyond that class. However, in this case, we don't necessarily want that. All right. There are times, but it's not always. Generally speaking, they're private. Now, there are several types of variables. Instance variables, which I've already talked about, which are variables belonging to a class. There's also what is known as local variables, which are variables that belong to a method. So local variables are probably the ones that we think of most because remember when we first started Program 1, we did everything that had the main method. So all those variables are local because they belong to that method. So if you put it inside of a method, let's say, let's say even just something like a for loop, all right, and you declare in the for loop header there, you just put like int I equals 0. Well, that I in the for loop construction is a local variable because it's localized to that loop. So that's really why we kind of say the local variables. Whereas if they're in the class, they're belonging to the class object, not just to the method. So other methods, not just one, can access them freely. Now, important thing to note though is that Java does not have global variables. Other programming languages do, Java does not. Now, let's talk about creating constructors. So let's say we have a class called myClass. It may have multiple constructors. So the following is an example of no arg constructor that may be used for a class. MyClass, number equals 0, line equals null. Right? Obviously, number is probably like an int, and line is probably like a string. Right? Because it's a string, and strings are classes in Java, we can set it to null. You could also, of course, have constructors that would have parameters. So, for example, you could have myClass int number. Then number would be like this dot number equals number or something like that. You can do different kind of setups here. Now let's jump into talk about mutators versus accessors. Remember, mutator methods typically are going to begin with the word set. Right? That's usually the key thing that ticks you off to know, hey, this is a mutator method because it says set. These will then change the value to the parameter value. So public static void set name, string new name, name equals robo. Then we also have, very similarly, public static void set name string name equals this dot new name. Notice both of these do the same thing. However, the big difference here is, and this is the way I prefer to do it, is I create a new parameter name so I don't get confused with this. Whereas like here, use the this invocation so you can use name over again in your parameter. Right? If you don't use this, otherwise, if you don't have this here, without this being right here, it says name equals new name, and then it would pull this. And so it would be setting this to itself and wouldn't be changing the instance variable. It would just be changing the parameter, which of course wouldn't really do anything. So for me, I always use this one. But again, if you're comfortable using this, by all means, you can do that. All right. Now, the other type is accessor methods, and remember those typically begin with get because they're getting a value. Additionally, they return a value. All right, so we say that accessor methods return a value. Mutator methods change them. Accessor methods return them. So this value of whatever they're returning is defined in the method header. So public int get number, return number picked. All right, number picked is obviously an int that's been defined somewhere in the class, and public int get number is the method header. Because you see have the word int in there, it means that the number picked has to also be an int. Otherwise, you're going to get an error. If I had like public string get name, then return name picked would obviously have to be a string as well. All right, let's talk about using class object. You have used class objects when you invoked, for example, string length. Right? Or you could also say like string.trim, string.substring, whatever. All those are different methods that are available to the string object. Now, let's say if you have a custom class called myClass and you have a main class called main. Well, to create an instance of the object within the main class, you're going to have to type myClass object name equals new myClass. To invoke a method of that class, then you have to type object name dot myMethod. Conversely, though, there's also times when you may be able to call the method in class directly, myClass.randomMathMethod. The difference between the two of them, and I'll show that here in a second, is whether or not that method is defined to be static. If the method is not statically defined, you can't do the second option here. So this option right down here would not be available if the method is not static. If the method is static, yes, you can do this because that means that we're not expecting these values to change. But sometimes they're not static, and so you have to create an instance of that object. All right, so let's just jump over to the code real quickly because this one I actually want to show some demonstration with some of the stuff. So here I have a review demo.java, and here I have my review class.java. And in here I've created, I have the scanner here, I have public class review class, int input scanner kb equals new scanner system.in. This method gets input from the user by asking for a favorite number, system.out.print line, favorite number, int equals skipper next int, calls this method called output, and calls this method called input squared. All right, and of course I might want to output again here, so I'm just going to call output, and you notice that when I do this, there's no naming of the class here. There's no review class.output, and that's because output exists right here within the same class. So if a method exists within the same class, you literally just put the method name. Right? So this right here and also input squared are both examples of a helping class because they're private. Right? They're not being used by the user. The user doesn't need to have output or input squared, right? Unless you want them to. Like if I wanted to change this to public so the user could use it, if I say, hey, I want the user to be able to output that value, I just change it to public, and now the user can use it. All right, but they probably may not need input squared. They may need it. Who knows? It just depends on ultimately what you want your program to be able to do. All right, so I'm just going to leave that as is. Let's go ahead and go over the review demo. Now, let's go ahead and first go ahead and make our review class object equals new review class. Now you notice what I've done here is I've gone and created a no arg constructor. But if we look here in review class, nowhere did I make a no arg constructor. And the reason why we can do that is because Java says that if you don't have a no arg constructor, it's going to automatically create one. There are advantages to explicitly defining the no arg constructor here, because then we can say like, input would be automatically set to 0, blah, 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 and all that. We can also define input right here. We can say int input equals 0. Okay. But let's just go ahead and leave it like that. Now, if I want to say object dot, I can of course invoke anything that would be, you can see it pulls all this other stuff up. But if I want to pull up, here's input, here's in KB. So I want to invoke input. All right. So if we look here, we have a class right here called user input. All right. And so right now I have user input here. So let's just go ahead and run this. It says please enter your favorite integer. So let's just say I type in the number 5. All right. This is the value of input is 5. The value of input is 25. So our program has worked correctly. Now, if we wanted to maybe condense it down a little bit, I could technically come over here and change, let's just say I change this here to static. All right, I'm going to change this to static. Now the issue is when I do that, it breaks a bunch of other stuff, right? Because you can see that input gets broken, output gets broken, all these other ones get broken, right? So let's just say, let's say we change this one here to static, right? And of course it still complains about input, right? Or if I change, let's say, get input here. Right? Again, input is getting complained about because it's a non-static field. Right? There's another thing I want to also mention here in regards to that variable. If you notice right now, it is not defined as private or public. And if you recall, we should always define our variables as private unless otherwise noted. So I'm just going to go ahead and change it to private. And because I'm not really going to worry about what's going on with these, I want to maybe make a method static. So I can add the word static in front of it. It doesn't really affect things, it just means static is not changing. Final means you can't change it at all. So I'm not going to worry about that. So public static final input. Now I could technically invoke that object directly. So like if I go to review class, I could technically put dot, and you can see input doesn't show up because right now I don't have anything. All right. But if I go ahead and add the static modifier to, let's say, oh, that one's got a lot of stuff. Let's just go right down to, let's go ahead and add here. Okay, public static void user input. Doesn't know what KB is, which means I need to make this a static as well. And then it looks like the two methods down here. All right, static and static. Okay, so now everything's static. Let's go ahead and look over here and go ahead and hit dot. And if we want to go ahead and invoke that method, which was user input, you can see that it is now just calls that directly. I don't have to create an object of that class. So if I run it, let's do the same thing. Let's put 5, and we get the exact same output. Even if I run it again, just to show that, hey, it's a different thing, 6 and 36. Boom. All right. Both are exactly the same output of how you can do it. How you ultimately choose to do it is up to you. If you're more comfortable doing it the first way I showed this example, that's fine. If you're more comfortable doing it the second way of the example, that is also fine. Right? So you're going to, in your lab, create a method. I'm probably going to give you the review class here, so you can make something like that. I might rename it a little bit, but otherwise you're going to be using this class, and you're going to end up creating your own secondary class, because I want you to create your own class object to invoke and call from. All right, and I think that wraps it up for today, folks. So until next time.